Welcome students. In this video series, we are seeing data structure, tree and graph. We have completed the tree part. Now we will see the graph. First of all, the very first question that come in our mind is why graphs are useful. Graphs are widely used to model any situation where entities or things are related to each other in pairs, right? Wherever there are the things which are related in pairs, at that time there will be a concept of graph. For example, the following information can be represented in the form of graph. Family trees, in which the member nodes have an age from parent to each of their children, or transportation network, in which nodes are airports, intersections, ports, etc. The ages can be airline, flights, one-way road, shipping routes, etc. For example, if you want to go from Pune city to Mumbai and from Mumbai to Delhi, then if you join these things and if you come back from Delhi to directly Pune, then this type of things will be formed. So this particular thing is having a different shape or different relation, and that relation is in pairs, and hence it can be represented in the form of graph. So this is the reason why graphs are useful. So if you know the reason why graphs are useful or why we need graph, then it will be easy for us to understand the definition of graph. So let us see the definition of graph. It is very easy definition to understand. A graph G is defined as ordered set. It is an ordered set where V comes first and E comes afterwards. In this ordered set, V means vertices and E means edges. That's it. This is the definition of a graph. I will repeat it once again so that it will be helpful for you to understand and memorize the definition. A graph G is defined as an ordered set V, E, where V of G represents a set of vertices and E of G represents the edges that connects the vertices. Now the first question comes in your mind is that what do you mean by vertices and what do you mean by edges? So let us see what are vertices. In this figure, if you observe, there are different nodes which we call these particular thing in circle. We have called it as nodes in tree or child or root. But in graph, we have given them a different name, and that different name is vertices. So in this graph, this A, B, C, D, E are called as vertices, and the line joining them is called as edges. So if you say that this is the edge BC and this is the edge CE and this is the edge DE, right? So it is a very easy concept of graph. So how many nodes are there in the graph? In this graph, there are total 5 nodes A, B, C, D and E. And how many edges are there? Total edges are, this is one edge, this is second edge, this is third edge, this is fourth one, this is fifth one, and this is sixth edge. Total 6 edges are there, 5 nodes and 6 edges are there in the graph. A graph can be directed or undirected. In an undirected graph, the edges do not have any direction, and in directed graph, the edges will have direction. For example, in this diagram, if you see, the edges don't have any direction, hence this graph is called as undirected graph. And if you give some arrow to the edges, like from A to B, like this, then this type of graph is called as a directed graph where the edges will have a direction. Hence, this type of graph is called as a directed graph. So this is the concept of directed and undirected graph. Easy. Now, as usual, we will see the graph terminologies. What are the graph terminologies? Graph terminologies. First, we will see the graph. Graph is a collection of nodes and edges which connects the nodes in the graph. So in this diagram, these are the vertices and these are the edges, right? Then we will see what is a node. And individual data element of a graph is called a vertex. Sometimes it is also called as node. Vertex is also known as node. In the above example, the graph A, B, C, D and E are known as vertices, which we have already seen. Then third terminologies which we have already discussed, that is edge. The edge is a connecting link between two vertices that can be either directed or undirected. We have discussed it already. Then directed graph we have covered, undirected graph also we have covered. Now we will see the degree of node. The number of edges connected directly to the node is called as the degree of a node. Then there are two types of degrees. One is in degree and another is out degree. If the G is a directed graph, then the in degree of a vertices is the number of edges from which it is head. That is the number of edges coming to it. Total number of arrows coming towards a particular vertex is called as in degree, and total number of arrows which are going out of the vertex is called as out degree of a graph. So let us see an example of this. I will draw a graph. On your screen you are seeing a directed graph where I have drawn the arrow in red color. Then if you want to know what is the in degree of A, then you have to first count how many arrows are coming towards A. There is only one arrow coming towards A, and hence its in degree is 1. What is the out degree of A? For that we have to calculate how many arrows are going out from A. There is only one arrow going out from A, hence its out degree is also 1. For example, if you see B, then two arrows are coming towards B. One is from vertex A and another is from vertex D. Hence the in degree of B is 2. And what about out degree? Out degree of B is only 1. So this is the concept of in degree and out degree. Now one more important concept is there. That concept is adjacent node. If V of I and V of V of J is an edge in G, then we say that V of I and V of J are adjacent, and the edge Vi, Vj is incident on Vi and Vj. So what is adjacent? If Vi, Vj is an edge, right? Suppose in a graph, I will draw one graph here having three vertices, then this and this. I will give the name to the vertices as A, B and C. Now if you see this AC edge, then A and C are called as adjacent edge. Now in this case A and B are also adjacent edge. AC is also adjacent edge, and adjacent node, and C and B are also called as adjacent node. I will extend this graph and I will take one more node, one more vertex D, and I will join CD, and also I will join BD. Now in this graph AD, these are not adjacent because there is no direct edge connecting from A to D. Hence A comma D are not adjacent, but B comma D are adjacent. Likewise C comma D are adjacent, C comma B are adjacent, but A comma D are not adjacent because there is no edge joining directly from A to D. So this is the concept of adjacent node. Now what remains? The only thing remains is successor. What is successor? If V1 is adjacent to V2, V1 is called as successor of V2, right? And predecessor, if V1 is adjacent to V2, then V2 is called as predecessor of V1, right? For example, if this is an edge AB, if this is vertex A and this is vertex B, and there is an arrow from A to B, then who is successor? Successor is A. And who is predecessor? Predecessor is B, right? ठीक. Then the last terminology is path. In exam they will ask you define path, define adjacent node. So you have to define it properly. You have to remember the things. Now three terminologies are remaining: path, length of path and cycle. What is path? A path is a sequence of distinct vertices. For example, in this diagram, what is the path from A to C? The path from A to C is A, B, C. So in this diagram, what is the path from A to D? A, B, C, D is the path from A to D. So what is a path? A path is a sequence of distinct vertices, each adjacent to the next. Then length of the path. The total number of edges in the path is called as length of a path. For example, what is the length of path from A to D? There are number of edges 1, 2, 3. So the length of this path is 3. Cycle. A path from a node to itself is called as a cycle. For example, in this graph there is no cycle. If I draw a line like this, then it will form a cycle. If I draw a path from A to D like this, then it will form a cycle. If I draw a path from D to A, then it will form a cycle, because from A I can go to B, I can go to C, I can go to D, and from D I can again come back to the original vertex. So hence this is forming a cycle. So that is the concept of cycle. Then in next video we will see representation of graph. There are two types of representation: adjacency matrix representation and adjacency list representation. So there will be a question on these two topics, and there will be a question on graph terminologies. After that your syllabus ends. So we will take one more video lecture on representation of graph. In next lecture we will discuss that.